Hello everyone and welcome back to another video. Today we are completing part 2 of the RF3 slope outcome. In the previous video, we talked about exactly what the slope of a line was and how to use the slope to graph a line. So we learned in the previous video that the slope of a line really can be boiled down to essentially how many units is a line moving up or down compared to how many units towards the right it's moving, otherwise known as your rate of change or your rise over your run. We're going to be applying that concept to a number of questions here today, as well as relating it to what rate of change is in particular contexts. So starting off with this question, it says Yvonne recorded the distances she had traveled at certain times since she began her cycling trip along the Trans-Canada Trail in Manitoba from North Winnipeg to Grand Beach. She plotted these data on a grid. What is the line through these slopes? The first step here is to identify 2 points to use. So we can use any of these 3 points. So I'm going to choose the first 2 here. So we know that this first point here is going to be 124. And the second point here is 248. I can label this as my x1, y1, and then my x2, y2. I'm going to use my slope formula to help us out here. M is equal to y2 minus y1 over x2 minus x1. I'm going to plug in all of my known values. So m is equal to 48 minus 24 divided by 2 minus 1. So in this case, I know that m, or our slope, is equal to 24 over 1. The second question asks, what does the slope represent? Well, we know earlier that our y values, and we're going to be taking that from our graph, we know that our y values represents our distance in kilometers. We can compare that to our x values, which is really just our time. So we can go ahead and we can actually tag those units onto our slope. We know that m is a change in your distance, and in this case it's kilometers, over your change in your x, which is really just your time in hours. So we can interpret our slope to be 24 kilometers per 1 hour. Now, for everyone who's ridden in the back of a car before, we know that your speed of your car is measured in kilometers per hour. So this slope actually represents your speed of Yvonne as she is bicycling along the Trans-Canada Trail. So her slope just represents her speed of 24 kilometers per 1 hour. Now we're also asked, how can the answer to part B be used to determine how far she traveled in 1 3/4 hours and the time it took for Yvonne to travel 55 kilometers? So there's a few different ways to approach this. I'm going to approach this using the content back in M1 and 2. So that was understanding how to use measurements, so calculating proportional reasoning as well as unit analysis. Let's set up our proportions here, or we can actually start off with unit analysis. If we are looking at how far she traveled in 1 3/4 hours, we know that 1 3/4 hours is really the same thing as 1.75 hours. So we can set this unit analysis up as 1.75 hours multiplied by our speed, which was 24 kilometers per 1 hour. We can actually get rid of our unit of hours, and we're left with 1.75 multiplied by 24 kilometers. We end up getting 42 kilometers. So therefore, she travels 42 kilometers in 1 3/4 hours. For the next portion there, how long did it take for her to travel 55 kilometers? I'm going to use proportional reasoning for this one. So we know from our slope that she travels 24 kilometers per 1 hour. This ratio, or this proportion, has to be the same thing as her traveling 55 kilometers per x hours. So we label that lower portion there with x because we don't know how long or how many hours she's been traveling, but the proportion has to be the same if we're considering that she keeps a constant speed of 24 kilometers per 1 hour. Let's go ahead and drop our units. So we've got 24 over 1 is equal to 55 over x. And we're going to cross multiply and then solve for our unknown variable x. So 24 times x gives me 24x, and 1 times 55 gives me 55. I'm going to divide both sides by 24, and I end up with about 2.29. So x is equal to 2.3 hours. So about 2 1/3 of an hour. So it takes her roughly about 2 hours and 20 minutes. A little under that. That's not quite a third. Okay, so about 2 hours and 20 minutes. And that's how we would solve this type of question and understand that slope can actually give us some sort of unit rate that's actually quite helpful in a real life scenario. Just a quick review of our previous lesson. We talked about slope in terms of 4 different characteristics, whether slope can be positive, if it can be negative, 0, or undefined. So let's see how much of you guys can remember of last lesson you guys can remember. So I'll give you guys a second here to try it out on your own. And let's go and check out our answers. In example A, we can see that going from left to right, our line is actually going downwards for every 2 units, roughly about a little bit more than 1 unit that we're going down. We're going to move about 6 units to the right. So this is roughly a slope of -1/6. So this is going to be a negative slope because going from left to right, our line is going down. For B, we're going to have a positive slope because we are moving up from left to right. In part C, we are actually going to have an undefined or not defined slope. So it's an undefined slope because there is no run. Okay. If we have no run, it really just means that there is no change in x. If there's no change in x, it means that our run is 0, and any rise divided by a run of 0 has to give us an undefined slope. In part D, we're going to have a 0 slope because we have no rise. There's no change in your y values, so that means that your rise has to be 0. 0 divided by any run is going to still be 0. In this example here, we're actually given each of our data points that we're going to have to graph, and then we are going to calculate the slope as well as answer a couple of different questions. So starting off with our x and our y-axis, let's come up with a reasonable scale for this. We know that along our x-axis, we're actually going to be representing our volume of aluminum in cubic centimeters. And then along our y-axis, we're talking about the mass of aluminum in grams. So we've got the mass in grams, and then we've got the volume in cubic centimeters. Let's go ahead and set up a scale along the x-axis, something reasonable, let's say 50. So we'll go up by 50 here. And then along the side, let's go up by, let's say, roughly 200. All right, so our first point says that we have 64 cubic centimeters of aluminum for every 172.8 grams it is. So here, roughly about, you can say about here, is where our first data point would be. Our second one, we're at 125,337. So 125,337 is probably around here. And then last but not least, we've got 216 and then about 583. So roughly about here. So we can see that, of course, the spacing isn't necessarily even, and that's okay. We're actually going to learn a little bit more about what type of relationship this is in RF4, RF5, characteristics of linear relations. But for now, let's just interpret the data as is. We're asked to calculate the slope of the line through the points. So if we were to draw a line through these points, so it kind of looked like this, which really isn't too bad for freehanding it. But again, let me reiterate where those points are. So we got one here, got one about here, then we got one last one right there. Let's calculate the slope. And of course, we just want to take any two points on the graph. So let's take the two smallest values. And let's say this is my x1, that's my x2, this will be my y1, and this will be my y2. So using my slope formula, I've got m is equal to y2 minus y1 over x2 minus my x1. So we plug in our values there, 337.5 minus 172.8 divided by 125 minus 64. Let's go and simplify this. You might want to grab your calculators. So 337.5 minus 172.8 divided by, we got 125 minus 64. This will give us 164.7 divided by 61. So this doesn't help us out an awful lot just yet. If we simplified this, if we actually took our decimals 164.7 and we divided it by 61, this would give us roughly 2.7. Okay, so we could actually simplify this further to 2.7 divided by 1. Now that slope, again, that value of 2.7 over 1 doesn't really mean a lot to us, but if we go back and we think about our slope, and we know that your slope is equal to your change in your y over your change in your x, otherwise known as your rise over your run. What is our change in y here? Our change in y is actually looking at our mass change in grams. So we can think of that as your change in grams over your change in your x values, which is your change in your volume, so per cubic centimeter. So we can actually go ahead and say that our slope represents the relationship of 1 cubic centimeter always weighing 2.7 grams. So here we can actually state that our relationship between the weight and the volume of aluminum is that for every 1 cubic centimeter of aluminum, it's equal to 2.7 grams weight-wise of aluminum. Okay, that's the relationship that we have seen here. So we can actually use the slope to figure out what's the mass of our volume of aluminum. Again, using our M12 outcome, using unit analysis, we are being asked what happens if we have 50 cubic centimeters of aluminum. We're going to multiply that by our proportion. We know that we have 2.7 grams per 1 cubic centimeter. We can get rid of our units there, and we'll end up with 50 multiplied by 2.7 grams, and this is equal to roughly 135 grams of aluminum. So we can state that 50 cubic centimeters of aluminum is equal to 135 grams of aluminum. For the next one, we know we're working with 275 cubic centimeters of aluminum, and we're going to multiply that by our proportion. We know that we've got 2.7 grams per 1 cubic centimeter. Let's get rid of our cubic centimeters, and we're left with 275 multiplied by 2.7 grams. So 275 times 2.7 grams is equal to 742.5 grams of aluminum. Okay, so we know that 275 cubic centimeters of aluminum is equal to 742.5 grams of aluminum. And for the last question here, what's the approximate volume of each mass of aluminum? So now we're going to work backwards. We can use proportional reasoning. There's a whole bunch of different things we can do. We know that, again, we can use this conversion rate of 2.7 grams is equal to 1 cubic centimeter. We can convert that into a ratio. 2.7 grams per 1 cubic centimeter has to be equal to 100 grams over x centimeters. And I'll add my units here, per x cubic centimeters. So we can drop our units, and we're just going to cross multiply. So we'll multiply those two, And we'll multiply those two, and we'll end up with 2.7x is equal to 100. If we solve for x by dividing by 2.7, we'll end up with about 37.03, but we'll just say 37 grams, or sorry, not grams, 37 cubic centimeters. So 100 grams of aluminum roughly takes up 37 cubic centimeters of space. And last but not least, if we have 450 grams, we're going to set up the same proportion. So we've got 2.7 grams per 1 cubic centimeter is equal to 450 grams over x cubic centimeters. Let's go ahead and cross multiply, and we're left with 450, and I've just gone ahead and dropped the units. So 450 is equal to 2.7x, and 450 over 2.7 gives me about 166.7 cubic centimeters is my x. So 167.7 cubic centimeters is equal to 450 grams of aluminum. And that's what our solution there represents. On this page, we're going to talk about slope as a rate of change. And I can hear all of you guys behind your computer screens saying, wait, Mr. Liu, you said slope and rate of change are the same thing. Well, really, they are the same thing, except the situations where we call something a slope versus a rate of change is going to be a little bit different. So to separate the differences between the two in your head, you want to think of slope as something that we would use without context. So we don't really have a lot of background information. And really what that means is if I were to give you an example like this, and I said, find me the slope of that line, that would be entirely appropriate because there's no context of what's happening there. You could find me the slope of the line by looking at 2 points and saying maybe, for example, that this slope of this line happens to be, I don't know, 4 over 3. Okay, that happens to be the slope of the line. But there's no context. What does that slope of 4 over 3 represent? On the other hand, if we talk about rate of change, we can talk about it as slope with context. So we're going to add some sort of context whenever we refer to slope as a rate of change. And in this case, we're going to represent this with an example of something perhaps that looks more like this. So if that's the graph of our line, I could say that perhaps along the bottom here, and I'm going to erase part of this graph, I'm going to say that along the bottom, this is our time, and then in seconds, and then over here on the y-axis, let's go ahead and label this as height in feet. And we could say that your slope of this, or your rate of change, is 4/3. But really, because we know that this is our change in your feet over your change in your time, we could rewrite this as your rate of change is 4 feet per 3 seconds. So every 3 seconds you go up 4 feet. We could simplify that and say that we go up roughly about 1.3 feet per 1 second. Okay? So that's really the biggest difference between your slope versus understanding slope as a rate of change. So let's go ahead and work through these examples together. It says that the world population increased from 5.76 billion in 1996 to 6.37 billion in 2006. Determine the rate of change in the world's population. Now, at first glance, it doesn't seem like this question gave you a lot to work with. We need to first understand that in order to calculate the slope or the rate of change of something, we need 2 points. So where do my 2 points come from? We're actually going to be looking at two separate data points here. We look at 5.76 billion in 1996, and then our second point, we go up to 6.37 billion in 2006. So if I were to pull two pieces of data from there, and we use usually our time as our x value or our independent variable, we can pull two pieces of data. The first one being that in 1996, we have 5.76 billion people. And then in our second data point, we went up, 2006, we went up to 6.37 billion people. So we can label our x1, y1, and our x2, y2 for each of those two data points. And let me move some of this older stuff out of the way. So we know that using our slope formula, m is equal to y2 minus y1 over x2 minus x1. We'll get 6.37 minus 5.76 divided by 2006 minus 1996. This gives us roughly about 0.61 over 10, and 0.61 divided by 10 gives us 0.061. So that gives us 0.061. Now, as a rate of change, I'm going to go ahead and rewrite that as 0.061 over 1. With that rate of change in mind, we know that that change in your y values, which is really just your population in billions. So this, we could rewrite that. We know that this represents a change of 0.061 billion people per 1 year. So you go up 0.061 billion people per 1 year. That's our rate of change. That's really our slope with context for this problem. For this next question, it says that a mechanic has tracked the amount of gas leaking from his car using the following graph. What's the rate of change? The graph has already given us two lattice points that we can use, the first one being 4, 3, and the second one is 8, 6. I can label these as my x1, y1, and then my x2, y2. We'll once again look at our slope formula and plug in our values. So we've got 6 minus 3 over 8 minus 4. This gives us 3 over 4. And if we look at it as a rate of change, that would really just be 3 gallons per 4 minutes. Now, again, this doesn't tell us a lot because we don't really measure things per 4 minutes. So if we go ahead and we simplify this a little bit, we know that 3 divided by 4 gives us 0.75. So that 0.75 divided by 1, we know that this is 0.75 gallons per 1 minute. So we can go and interpret this rate of change as the mechanic is leaking gas at a rate of 0.75 gallons per 1 minute. So 0.75 gallons of gas is leaking for every 1 minute that goes by. In this question here, it says that John is a meteorologist tracking a storm on Misty Mountain. He's working on his next newscast and is attempting to figure out how much snowfall there has been over the past few hours. What is the rate of change? So in this question, we are required to find our 2 points that we're going to use to calculate our slope or rate of change. We can actually go and use the one right at the origin, which will be just a 0, 0. And then another point, we're going to look for a lattice point. Let's use this one right here. And that one is for 8. We've got our x1, y1. And then we've got our x2, y2. We can calculate our slope using the slope formula. M is equal to y2 minus y1 over x2 minus x1. So m is equal to 8 minus 0 over 4 minus 0. And that gives us 8 over 4. And we can simplify that to 2 over 1. Now, because we are looking for the rate of change, we're looking at this in terms of its context. This would be the rate of change representing 2 inches of snowfall per 1 hour. So we can say that 2 inches of snow falls every hour. The last question here, it says that Freddie tracked how quickly his candle melted using the following graph. Determine the candle's rate of change. So we're given 2 points to use here. We've got 0, 10, and then we've got 37. Again, we can label our x1, y1 and our x2, y2. Using our slope formula, m is equal to y2 minus y1 over x2 minus x1. we have m is equal to 7 minus 10 over 30 minus 0. So this gives me a negative 3 over 30. And I can simplify that to negative 1 over 10. But again, we typically do things per 1 unit. So if we were to simplify this, we get m is equal to negative 0.1 over 1. Since the question is asking for a rate of change, we're looking for the context. We know that our change in y is going to be our candle length in inches. So this is negative 0.1 inches per 1 minute. So here we can state that the candle melts at a rate of 0.1 inches per minute. So note that I said that it melts at a rate of 0.1 inches per minute. We don't want to say that it melts at a rate of negative 0.1 per minute. We've already implied that it's melting with that negative slope. So we can state in this context that since it's melting, we don't need to mention that it's a negative 0.1. It's just melting at a rate of 0.1 inches per minute. Now, the last section of RF3 talks about the slopes of parallel and perpendicular lines. You guys have talked about parallel and perpendicular lines in the past in other math courses, but we're going to revisit them through the lens of using slope. So parallel lines here, we need to identify what's so special about their slopes. So the first thing that we need to do is identify what it means for two lines to be parallel. And in this case, parallel lines really just have the same slope. So if they have the same slope, they are parallel. In our example here, we have AB and we have CD, and we can see that they both have a slope of 7 over 5. They both go up 7, and they both go 5 to the right. Up 7, and then 5 to the right. So we can see that they will never ever intersect. They have the exact same slope. Looking at a few different examples here, we have line GH passes through G, which is negative 4, 2, and H, 2, negative 1. Line JK passes through J, negative 1, 7, and K, 7, 3. Line MN passes through M, negative 4, 5, and N, 5, 1. Sketch the lines. Are they parallel? And justify the answer. So what I'm going to do is I'm going to actually graph or plot each of these lines first. So we're going to look at G and H. So we've got negative 4, 2, which is right about here. We've got H, 2, negative 1. 2, negative 1 is over here. I'm going to connect those with a straight line. And then we've got line JK, pass through negative 1, 7, and 7, 3. So negative 1, 7 is up here, and 7, 3 is down over here. Once again, we'll connect those with a straight line. And last but not least, let's look at line MN. So we've got negative 4, 5, and then 5, positive 1. Put a straight line through those. And we're going to first examine the lines. Are they parallel? Your first instinct, you might think, okay, yes, they might be. If you're looking at a quick inspection here, you want to be able to just look and see, okay, are all three of them parallel to each other? And the answer here is going to be no. Just a really quick glance here shows that if you were to look at this point here compared to this point, there's 3 units, 1, 2, 3 between those. And if you take any 2 points here, if you're looking at this point and you come down, it's just a little bit wider of a gap. So not all 3 of them are parallel to each other. But is there any evidence that 2 of them are perhaps parallel to each other? Well, the question is, are their slopes the same? Let's go ahead and calculate the slope of each of these lines. The slope of G to H can be found by taking negative 1 minus 2 over 2 minus a negative 4. And that will simplify to give us negative 3 over 6, which is the same thing as negative 1/2. The slope of J to K can be found by taking 3 minus 7 over 7 minus a negative 1. This will give me a negative 4 over a positive 8. So we get M is equal to negative 1/2 when we simplify it. Last, for slope mn, this is going to be equal to 1 minus 5 over 5 minus a negative 4. And I can simplify that to give me a negative 4 over a positive 9. So we can see here, if we're comparing all of the slopes, we have two of the same slope. So we have g to h and we have j to k are parallel. So we can state that the slope of jk and the slope of gh are the same. Therefore, jk and gh are parallel. So again, they're parallel because they have the same slope. Mn, unfortunately, is not parallel with either of those lines because it does not have the same slope. The next question here, we're going to start off by, again, just plotting our points and calculating the slope. So we got negative 3, negative 2, and then negative 1, positive 6. Let's plot a line through those points. Next, we look at line CD, negative 1, negative 3, and then 1, 7. Last but not least, we've got A, negative 3, 7, and B, negative 5, negative 2. So we've got a set of 3 lines, and all I need to do here is calculate the slope of each line and figure out if they do in fact have the same slopes or not. And at first glance, perhaps they might. It's hard to tell. So that's why we're going to do this mathematically. So first, slope EF, we can calculate using 6 minus a negative 2 divided by negative 1 minus a negative 3. I can simplify this into 8, and then negative 1 minus a negative 3 gives me negative 1 plus 3, which gives me a positive 2. So the slope of EF is actually 4. Next, the line CD. So the slope of CD is given by 7 minus a negative 3 over 1 minus a negative 1. And this can be reduced to 10 over 2. So the slope of C to D is actually equal to 5. Lastly, we've got the slope of A to B. And this is given by negative 2 minus 7. Negative 2 minus 7 over negative 5 minus a negative 3. The slope of AB can then be represented as negative 9 over negative 5 minus negative 3. That is negative 5 plus 3. That's negative 2. So I get the slope of A to B is equal to a positive 9 over 2. So an interesting turn of events. None of these lines are actually parallel to each other because none of the lines have the same slope. So to summarize our answer, we can state that none of the lines share the same slope. Therefore, they are not parallel to each other. In this next section, we are now going to look at perpendicular lines, which is really just the opposite of parallel lines. So you understand that parallel lines have the exact same slopes, meaning that the lines will not ever cross or intersect. Perpendicular lines, on the other hand, will have different slopes, but just how different will they be? There's a lot of reading to do on this page, so I'm just going to quickly draw your attention to the most important part here. The slopes of two perpendicular lines are going to be negative reciprocals of each other. So any two lines that are perpendicular will always have a negative reciprocal. Now let's review a little bit about what reciprocals are. So just the regular reciprocal just means that if I were to take a fraction of 3/4, the reciprocal of 3/4 is just 4 over 3. All we are doing is we are flipping your numerator and your denominator. So we're moving the top and the bottom numbers, we're switching their positions. So this would be the reciprocal. They would be their own reciprocals. And we know that they're reciprocals because when we multiply them together, the product of 3 over 4 times 4 over 3 is equal to a positive 1. Now, if we look at negative reciprocals, if we look at a few examples, 5 over 2, the reciprocal of 5 over 2 is 2 over 5. Because we are now looking for the negative reciprocal, what was originally a positive fraction, we are now going to turn it into a negative fraction. So we can see the 5 over 2 is positive. That means that the negative reciprocal has to be negative. And if we were to multiply the two numbers together, so if we took 5 over 2, multiplied it with a negative 2 over 5, we get an answer or a product of negative 1. Now, conversely, if I were to take negative 6 over 7 as my original slope, the negative reciprocal would now have to be 7 over 6. Now, why don't I have a negative sign on the second slope? Well, it's because the original was a negative slope already, which means that the line that's perpendicular to it has to have a positive slope. Now, the only exception to this rule of having one positive and one negative slope is highlighted down here, that horizontal and vertical lines are going to be an exception. So the slope of a horizontal line is 0. The slope of a vertical line is 1 over 0, which is not defined. So their slopes are not negative reciprocals of each other. So on this page, we're going to examine the slopes of different lines to figure out if they are parallel, perpendicular, or neither. Line PQ passes through negative 7, 2, and Q, negative 2, 10. Line RS passes through negative 3, negative 4, and S, 5, 1. To calculate the slope of each, we're going to go and use our slope formula. Let's go and plug in our values for PQ. So we've got 10 minus 2 over negative 2 minus negative 7. And we get 8 over a positive 5. Because the bottom will give us negative 2 plus 7. So we get a slope of negative 5, we get a slope of 8 over 5 for line PQ. Then taking a look at slope RS, or line RS rather, substitute in our values, 1 minus a negative 4 over 5 minus a negative 3. We'll get the slope of RS is equal to 5 over a positive 8. So we've got our two slopes here, and we need to come up with some sort of analysis. We've got 8 over 5 and 5 over 8. Now what these two slopes show us is that their slopes are reciprocals. Not negative reciprocals, just reciprocals. Their slopes are also not the same, so we know for a fact that these are not parallel. Are they perpendicular? Well, we know that perpendicular lines have slopes that are negative reciprocals of each other. 8 over 5 and 5 over 8 are not negative reciprocals, so they can't be perpendicular. So in this case, they happen to be neither. So in order to justify our answer, we can say that the slopes are not the same, so they're not parallel, and their slopes are not negative reciprocals, so they're not perpendicular. Therefore, the lines are neither parallel, perpendicular. Let's sketch the lines to verify our answers. We're going to do that first by plotting PQ and then RS, and then we'll draw a line through each set of points. So we can see here that they are most definitely not parallel, nor are they going to meet at a 90-degree angle. So therefore, we have done this question correctly. So for this next question, we'll fast forward a little bit. Let's first find the slope of ST. And let's calculate the slope of line UV. Then let's examine what we found. So we have two different slopes. We have negative 3 and 1/3. They are not the same slope, so they cannot be parallel. so we can right away eliminate that one. Are they perpendicular to each other? So if they are perpendicular to each other, these two slopes need to be negative reciprocals of each other. And we can confirm that if we were to multiply negative 3 over 1 and 1/3, this would be equal to negative 1, which means that they are negative reciprocals. So the slopes of these two lines are negative reciprocals, therefore they are perpendicular. Or we can verify our answer by plotting each one of the points and drawing a straight line through each set of points. So we can see that both lines will intersect at a 90-degree angle. So on this page, we're going to try to figure out if a four-sided shape, otherwise known as a quadrilateral, with these four vertices is a parallelogram or not. So if you don't remember what a parallelogram is, it is just a four-sided shape with two pairs of parallel lines. So in essence, we're looking for two pairs with each pair of lines having the same slope. Let's go ahead and plot these points and then connect each one of those points with the other ones. So let's go ahead and plot each of those points and then connect them so that we get a four-sided shape. Now I'm going to go ahead and label this. So you've got A down here, we've got B over here, and then we've got D and C. So really what we're going to be looking for is we're going to try to find out if A and B and CD are parallel to each other, and figure out if B and C and AD are parallel to each other. Let's go ahead and find out the slope of each line. Now that we've found the slope of each line, we can go and examine them. So first off, we looked at AB and CD. If those two lines are parallel, then their slopes also need to be the same thing. So we've got 5 over 2 and 5 over 2. So they are parallel. Great. Now our next step is to look at BC and AD. If those two lines are parallel, or if those two slopes are the same, then we also have another set of parallel lines. And we definitely do. So we can conclude that since AB is parallel, and that's the symbol for parallel lines, AB is parallel to CD, and BC is parallel to AD, ABCD is a parallelogram. So on this page here, we have two endpoints, 2, 3, and negative 4, 1. Let's go ahead and plot those and then draw a straight line through them. Then we'll label each of those points. So we're now being asked to find a point G such that EG is going to be perpendicular to my original line EF. So the first step that we need to do is figure out what the slope of E to F is. So we can do that graphically, or we can use the slope formula. So we know the slope of a line that is perpendicular to E to F needs to be the negative reciprocal. So the perpendicular slope would have to be negative 3 over 2. We know that that slope of negative 3 over 2 means we are going to move 3 units down and then 2 units to the right. But where do we start? Well, we're going to look first. We know that we're going to have a second line, which is going to be E to G. So starting from E, we need to find point G using this slope here. So we're going to count 3 units down and then move 2 units to the right, and we'll get a point right there. once I go and connect those 2 points with a straight line, we can see that we have created a 90-degree angle where they intersect. So this right here is our point G. We have a new line segment that is perpendicular to EF. Now, of course, that's not our only possible point for G. There's an infinite number of answers, really. If we were to continue here and we took another 3 points down, and then we went another 2 to the right, we're really just extending our line. So if we take a look, we can actually go and extend that line all the way down. So we could have a couple of different possibilities for G. So we could have the first one that we found, 4, 0, or we could have 6, -3, or we could actually, in fact, go the opposite direction. If we decide to reverse our slope, that is going 3 units up and 2 units to the left, we could also have 1, 2, 3, then 1, 2. We could also have another point G right here at 0, 6. So again, it just really depends on which way you decide to go with that next point. And for anyone who's trying out the second problem here, we need to first figure out the slope of GH, and then we need to figure out the perpendicular slope. And then starting from G, we'll count 3 units up and then 5 units to the right. So this coordinate for J is only just one of the possibilities. There are many, many more. So on this page, we're just going to be using algebra to determine a value of k that will make each of the following sets of slopes parallel. So again, parallel slopes just means that they are the same. So in the first example, we know that 4 has to be equal to k divided by 4. In order to solve for k, I'm going to multiply both sides by 4, and I get k is equal to 16. If I plug in my value of k back into the original, I'll get 16 over 4. That gives me 4. So I get two slopes that are both 4. Example B, I know that -2 has to equal to 2 divided by k. I'll multiply each side by k, so I'll get -2k is equal to 2. I'll divide both sides by -2, and I'll get k is equal to -1. Question C, I have 5 over 6. Question C, I have 5 over 6 is equal to 3k. I'll first multiply both sides by 6, and then divide both sides by 18. So I'll get 5 over 18 is equal to k. Question D, I'll have 3 over 4 is equal to -k over 6. I can cross multiply. So I'll get 4 times -k is equal to 3 times 6. So this will give me 18 is equal to -4k. I'll divide both sides by -4, and I will end up with -9 over 2 is equal to k. For the second part, we're more or less doing the same thing, except we're looking for a value of k that makes each set of slopes perpendicular. So what we need to do is just add an extra step. We're going to first look at the first slope in each set, and we're just going to look for the negative reciprocal before we begin. So the negative reciprocal for each one of these, I'll just quickly write them out on top. And we're now really just going to make that second slope equal to that perpendicular slope instead. In this case, I can just, instead of cross multiplying, giving myself some extra work, I'm just going to multiply both sides by 3, and I'll get k is equal to -1. For example B, I've got -1/4 is equal to 8 over k. I can cross multiply here. I'll get -k is equal to 32. Divide both sides by 32, and I'll get k is equal to -32. Part C, I've got -1 over 5 is equal to k over 2. I'll cross multiply. -2 is equal to 5k. And then dividing both sides by 5, I'll get -2 over 5 is equal to k. And finally, I'm going to have I'll have 4 over 3 is equal to -k over 6. I will cross multiply. giving me 24 is equal to negative 3k. Dividing both sides by negative 3 gives me negative 8 is equal to k. So that's the end of today's video. Hopefully you learned a thing or two about parallel and perpendicular lines. Make sure you guys are reviewing on a consistent basis. Until then, I'll see you in the next video.